Hi, my name's Abe and I'm going to be running you through an example of finding the derivative from first principles. And so today's example is quite simple. Find f dash of x if f of x is equal to x squared minus 3x plus 1. Let's get started. First thing to notice is that we're finding the derivative from first principles. So you need to write down this formula. F dash of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Easy, right? Hopefully you've seen that before. If not, feel free to check out my introduction to derivatives video. So yeah, let's continue. Here f of x is x squared minus 3x plus 1. So the first thing you want to do is replace f of x with your actual function. So let's go ahead and do that. Remembering to write limit as h approaches 0 each time at the start of your line. So f of x plus h is simply x plus h all squared minus 3x plus h plus 1. Now you want to do this. Minus all of f of x, right? Put f of x in brackets. X squared minus 3x plus 1. And all of that goes over h. Okay. The next few steps are just going to be algebra, which you're all really good at. So again, limit as h goes to 0. Now we expand this. We know that x plus h all squared, if you expand it, you're going to get x squared plus 2xh plus h squared. Expanding the next part, you'll get minus 3x minus 3h, and then you had plus 1, and then minus x squared. Let's take this f of x part out of the bracket, so you'll get plus 3x minus 1, and remembering that all of that goes over h. Okay, time to circle some stuff and cancel. You'll see on this line that there's x squared and minus x squared. There is minus 3x and 3x. There's minus 1 and there is a 1. All of these cancel out. Very good. Now what you'll notice is that all the terms that are left in the numerator all contain h. If that's not the case, you've done something wrong. So, simplifying things, writing again, limit as h runs to 0 of 2xh plus h squared minus 3h all over h. Simple, right? So in the next line, I can take out common factor of h from the top. So you get h and then 2x plus h minus 3 all over h. And simply enough, the h's will cancel like so. And so you're left with the limit as h approaches 0 of 2x plus h minus 3. Okay. So here comes the application of limits. What happens as h gets very, very, very close to 0 to this function? Oops, sorry. This part. What happens? H pretty much disappears, right? So the limit as h approaches 0 of 2x plus h minus 3 is going to be 2x minus 3. So pretty much in this case, we kind of just let h equal 0. And that's our final answer. F dash of x is equal to 2x minus 3. And to go back to the top, let's remind ourselves of what we've just done. We started with a function, x squared minus 3x plus 1, and we got a derivative, 2x minus 3. This derivative describes what the gradient is of f of x at any point. So, for example, the gradient of f of x at x equals 5 is going to equal f dashed 5, equaling 2, 5 minus 3, well, that equals 7. So yeah, this derivative function actually means something. Okay? Well, I hope you've enjoyed yourself and learned something. See you next time.